Hello, it's Greg. Today we will try to get the geometry directly from Tekla Structures, and we will be dealing with the left side of our data flow, so we will need to get the solid geometry and faces which are connected to that solid. So mainly Tekla Open API, that will be our main focus today. I think that exporter to dotbim, it will have two different modes. It can export to the whole model or just the selection. So as usually for almost every exporter from the Tekla, this is the typical way how they can be set up. So we will start with something quite simple. So we will want to write some selectors. And I think that it is quite a good place just to place some interface, because we, at the very beginning, we know that there will be two different strategies for picking. So let's just create something like Tekla selector, and it will have two different implementations. So it will be the related to all and only selected. Let's now think about better naming. Okay, all Tekla objects and selected objects. The interface and the implementation. Let's just try to write something inside of our project. And of course, we will be now working in the engine. So here, let's just provide some interface, and it will be here. So that's that, Tekla selector. And of course, what should be the return results? So I want to have it as a public, because we will write some integration test for that. And as a result, we will just get some immutable collection like I read only list or just I enumerable. It's only what we matter. And those will be model objects. And here there will be just the method get. So the Tekla selector will always return something. And yeah, now let's try to create some implementations. And as I said, there will be two of them. So it will be the all Tekla objects. This will be the first class, and it will just inherit from iTekla. It will implement iTekla selector. And the second one was selected objects. Okay, let's get it like that. So let's implement those interfaces. Here it is the first, here is the second. So let's think how it should be implemented. So for the all Tekla objects, we will start with just getting the Tekla model. I hope that we have that reference. Here it is. So inside of the model, I think that there are model object selector. Here it is. And this is something probably like the enumerator. Let's go to the definition, and that's the class which has the method get all objects. And yeah, at that point we will not think about objects with some specific type. Probably in the future we will change that interface and its implementation just to limit the objects to some particular types, but probably not one, but we will use that type filter. At that point, I just want to get all of those model objects. So I will get the selector, and then I will get all objects. So now this is not the model object selector, but the model object enumerator, and that is enumerator. So we can't use the for each. We will have just to loop with while as long as it is has the next element, then we will be able to get the current element. And yeah, the question is, should we use the yield return? Yeah, when we want to get executed that stuff. And I think that the current way is better, because we will probably not change how those objects look. We will not modify their properties during the calculation. So okay, that is the first implementation of all Tekla objects. Now the selected Tekla objects. And for getting the selected ones, we need to use different namespace. So we will use the user interface, and the typical shortcut for that is like that. So I will just add new reference, and here I am able to create new object of model object selector, and here it will be the get selected objects, and once more again it will be the enumerator, so I can just copy paste the previous code and it should look fine. Okay, so now I have it. So yeah, I have all Tekla objects and I have selected objects, and of course they are now in the same file. So now let's just convert it to the scope like that. Let's move it to different files. Here it is, and yeah. Okay, so that's the first idea. Of course, probably we need some better directories inside of our project, but yeah, at that point, I just want to check if those methods, do they work or not work? And I don't have the WPF or WinForms application, so I need to do it in a different manner. And I will use, for that purpose, integration test. So now I will write two different tests. The first one for getting all of the objects, and let's name it all Tekla objects. Here it is. And of course, that test will be very fragile to what is available in the model. You know, that if you change the model or modify its content, then that test will fail. But okay, at that point of development, I just need to check that it will work. So I want to check that class, and let's just write it with the test class. Okay, here it is. A little too much of the code, but okay. Test class, we have it. And now let's implement the test method. Okay, and that method was get returns correct number. Okay, let's create our system under test, and it will be the all Tekla objects. So the constructor is public, so it can be very quickly available. And now I just want to get those objects. So get, okay, here they are. And of course, we want to check them. So I think that this is the best moment to introduce the fluent assertions. And I really like the NuGet package because they make the testing much easier. So let's download the fluent assertion. Let's just be sure that it is compatible with our .NET framework. Okay, let's download it, and we will be able to write those tests in a much better. So now I can pick set should. Of course, let's add that using, and I can just say should have count greater than 1. That, okay, so it will not return the current number because at that point I don't know how many objects they are. So let's returns more than 1 object. Let's name it like that. Let's try to run the test, and let's see that it will fail or not. So here it is, and what is the result? Oh, okay, so it takes too much time, definitely. So probably here it is not the it is not enumerable, but here in the background, Tekla is truly getting all of those objects at once. Let's just see the task manager, what is going on the Tekla side, and probably the CPU is crazy. And let's see, not really. Tekla, yeah, okay, so now we see that the CPU is working at the most, so yeah, it's not the lazy evaluation on the Tekla side. That method will be very, very time consuming to get all of those objects, all of the booleans, all of those reinforcement, everything what is there. So okay, so probably we will have to think in a different manner, because now it took almost 1 minute to get all of those objects. So okay, let's think a little forward. What will be the typical use case of that export? So probably users will not be interested in the reinforcement, but rather in the assemblies. So I will now just try to think, okay, so maybe not get all of the objects, but I will change here that I want to get only objects with type, and I would like to use the type of assembly, the Tekla assembly. Now it should be much faster, but yeah, something is wrong. Okay, here is the enumerator, so it should be provided differently. Model object enum, and assembly. Okay, something like that. Let's see how long it will take. Because previously for the whole model it was 1 minute, very long time. Now it's just 4 seconds. Okay, so at that point it will be okay, but of course we need to change the name of the class because it is misleading. It is not all Tekla objects, but Tekla assemblies. So I will rename it. Okay, those are the Tekla assemblies. So our first test is not failing, so we are getting something. Of course, I will not check that we are getting, 5 assemblies, 500 assemblies, 5,000 assemblies. I don't care at that point. I just wanted to have something which will say very loudly, if it will fail, that something is wrong. So those, it is for the all Tekla objects, and I will make it as a Tekla selector tests. So I will try to use more generic name, Tekla selector tests. Okay, here it is. Of course, we don't have that class. So if you are strict to the convention that the test class should have the same name as the testing object, then yeah, I am violating that rule, but I'm just getting it I'm trying to be a little more fluent for assemblies, and here it will be for selection. Get and returns nothing. That will be the first test which I have in my mind. So here those will be not the Tekla assemblies but selected objects. Here it is. And if I don't have anything selected in Tekla like now, then the test should fail. And let's see that it will be true or not. So we are looking on that particular test, and it should be red one because currently in Tekla there is nothing selected. Okay, great. So yeah, it should have count 0 or be empty. It will be more strict. But of course, that test now is very fragile to in what state is Tekla. So if I will select something in the model, then the test will fail, but it should not. So unfortunately, we need at that point also some Tekla interaction. We need to enforce the state of the Tekla before testing our classes. So before running that test, I want to unselect everything from the Tekla, and I will do it in the most maybe that way, but let's find out. Tekla structures. Okay, now I see that I don't have the reference for the Tekla library inside of my integration tests, and the question is, should I have or not? And at that point, I don't want to spoil that library with those, so I will do something maybe a little crazy. So I will write those helper stuff, those helper methods, inside of our engine library. Probably later it will be separated to a different project, but at that point, let's just create a new directory, test helpers, and here I will create the new method just to maintain the state, the selection of Tekla objects, or just go with the lazy mode Tekla helper, and it will be super lazy. So it will be just the static class, which will currently have one method, and it will be unselect all. So inside of that method, I want to prepare. I want to prepare the scene, so the Tekla structures with the unselected all elements. And to do that, I will now create the, let's stick with the same. Okay, here it is. And now I want to create model object selector, and here it is select nothing, select, and here if we will provide empty array list, then they will be deselected. But we also need using system collection, so let's get it here, and here I want to provide empty list just to have some naming, and here I will provide it like that. So now I hope that when we will use the Tekla helper inside of our test just before, So here we are setuping the Tekla, then we are invoking our method, and we are checking what is the result. Let's find out that it will work or not. Great, now it works. But of course, we want to be sure that method will return exactly what is selected if there is something selected. So now I want to create some static method for select. And here I will specify just the identifier of the object. So here I need to grab that model object. For that I will go with some shortcuts, get model. Here I don't want to get, I want to select model object, and of course here I need to provide the proper identifier. So let's create the correct identifier, and it will be like that. So let's hope that we don't have to check that that model object exists or not. It's just a helper method for the testing purpose. So we will not test something which is meant for the test. And here I have to provide that. Let's provide better naming, and okay, it should be fine. So now I want to use that method select inside of my test. When I will have the second, maybe the third test method, get for selected returns one object. So now I want to use that helper method to select something inside of the Tekla. So for example, I will just get the identifier of that column. Here it is. So I will copy paste that, and it will be here. Okay, here it is. And now that test, when it was just copy pasted, it should fail on that line. So let's see that it will fail or not. And yep, it is failing. Great. So of course now it is failing because that collection, it has exactly one item. So b equal, sorry, have count. It should have count of one element. Okay, let's try now all of our selectors, and it should be fine. So for now, it's all. In terms of the selectors, of course. Yeah, I know that test is not the best one. It took very long time, and yeah, but I wanted to have something solid, something on which we will build the next. Of course, later we can just abandon the test, but at that point of development, we have that interface with two different implementations, so it's good to us. And yeah, this is the first one. So from that classes, we will get those Tekla objects selected, or all of them. Then we need to find out about their geometry. And of course, every part, every rebar, we can invoke the get method, the get solid method for querying the geometry information. But I want to think, okay, so yeah, we will get those face class from the Tekla Structures solid. We will get the loop, and I want to go into our entities, our classes, because maybe, I'm not sure, maybe the default implementation of the point, which is the class, maybe it will be not enough for us due to the performance. Maybe we will need to go to the structs, because in terms of the huge geometry, it will be needed. But at that point, I don't want to do the premature optimization. I just want to make a space when in the future, it will be much easier to dissect, to provide alternative implementation. So maybe we should try to mimic those classes. So I want to have my own solid class, solid or geometry. Yeah, maybe let's stick with the solid, and also my own face class with the outer polygon and inner polygon. So when I'm talking about the polygons, then we will need some implementation of the polygon class. So yeah. Let's just copy it here. What do we need? We need new classes. So solid, face, and face will have some polygons, the outer polygon and the inner polygons. So those two three objects, we need them. And of course, now we could draw the UML to make the composition of that, but I don't think that it is needed. We will just go deep into the code. So we need new classes, and now we see that, okay, in our project, it starts to look a little messy. So I will provide a new namespace for the selectors, and there I will provide that one, that one, that one. So it will be there, okay? And now I will provide the next namespace like entities. And okay, here, okay, the tests are failing because they don't know about that new namespace. Here it is. Of course, we could trigger those tests, but yeah, it's just a copy pasting files between two different directories. So it will be like that. And yeah, maybe it's time to make some commit about the selectors, because yeah, so Tekla selectors for getting all of assemblies or just selected objects. That will be okay. So we have the commit, and now let's look into the entities. So as I said, we will need something like the solid. It will be at the very beginning just a class. So I will need the solid, I will need the face, and I will need the polygon. Okay, and now what are the relations between those entities? Let's start with the face, because it is the easiest one. So the face has the property polygon like outer, and it is only the getter. Here I will have holes. Yeah, maybe not the outer, but contour. It is the better name. And here we have the holes. And yeah, for the holes, there will be 0, 1, or many. So here we need some type of the collection. And let's stick at the very beginning with the enumerable. Okay, here it is. And why it is not shouting that, hey, you can't have only the get. So yeah, my project is not configured as I would like to have, because usually I really like to raise the warning flags and stop the compilation if there are some warnings. So I want to use the warning level, one of the highest ones. So let's stick with that one, and let's see that it will stop me, that it will at the very beginning raise some warnings, but it's not doing that. Why is that? Let's also see here. Okay, here I have the warning level. Let's look once more to the properties, and here is where it was. Here it is. Instruct the compiler to read warning as errors. Exactly. I don't want to suppress anything. I just want to get that error, because okay, the problem is that inside of my CS Pro I don't have set the nullable, and it should be set to enable, and after doing that we will get the error. And yeah, I know that it is something counterintuitive, that now we are getting errors and I'm happy, but believe me that in the real development it will save your ass, because yeah, now we are getting those errors during the compilation or even before, because the Visual Studio will not allow us to compile our project, and not on the runtime on some machine on one of our clients. So now I just want to implement a basic constructor with that contour and that hole. Exactly, here it is. And of course, it's very easy to imagine that face will not have the hole, so it will be just with the contour like that. And then I want to set it as an enumerable empty of type polygon. Okay, here it is. And now we can of course invoke that full constructor from that one, and here I will just use the shortcut. Here is the contour and here is this empty enumerable, and it should work fine, or now it should work fine. Okay, here is some suggestion from the IntelliSense that we could use even that new collection expression like that, but for me it's less readable. So yeah, I will just stick with that one. Let's try to compile, and now we have the engine working. Okay, so the solid, what will be the solid? It will be the collection of faces, definitely. So yeah, let's just stick with that. So it will be the face, faces, something like that. Let's just stick with a very simple definition, and later we will just maybe add something more. And for the face, we need also one more thing. We need the vector, the normal vector for the face. So let's stick maybe here, and let's use the Tekla vector. Here it is, here it is. Okay, not sure that we will be using it as a class, but as I said previously, at that point I will not think too much about the optimization. So here we need to provide the vector normal, and yeah, the name vector is very misleading, so it will be the normal, and let's also pass that property somewhere here, and here it will be like that. Okay, so we have the solid, we have the face, and yeah, it's not set, so I will need just to add it, initialize, and also add null check. Okay, so we have the solid, the face, and now it's time for the polygon. And what is the polygon? The polygon is just a set of vertices, the points. So let's stick with the enumerable of the point, and it will be the points. Or maybe now let's provide it like that. Okay, so this is my first implementation of the solid, face, and polygon. I'm not sure that it will live long, but at that point it's all what I need. I will just move those to another files, and here it is. Okay, so we have the solid, face, and polygon, but they have to be somehow constructed. So we need a new class which will be able to get the Tekla object and convert it into our entities. So yeah, it will be some kind of a transformer. So let's create the new folder, and it will be the transformers. I'm not sure how many transformers we will need, but from the Tekla to entity, it is the first one. So yeah, it's the first name which it comes to my mind. Maybe not the best, but Tekla to domain transformer. So here it is. And what do you expect from the Tekla to domain transformer? You expect that it will take the Tekla object and do some magic to get the proper domain object, our solid, our internal solid. So that is what I expect to have. So let's write at the very beginning just one object to do that. So here I will expect that I will get the solid, our solid, and I will get the transform method, and at the input it will be some kind of a model object. Let's try it like that. It will be the Tekla object, but I am a little worried that maybe here is some error that Tekla Structures model, it has the solid. Ooh. Okay, we have the collision of different namespace, the same class. It has the same meaning and the same naming. So yeah, we could bend our knees and change the name our solid to something different, or we can say that Tekla, it's up to you to make a space. So I will, at that point, I will pick the second approach. So I will just add that kind of abbreviation. So let's just see that Tekla object, does it have the get solid? Not really. It has to be probably the part. And now we have the method get solid. And if we look a little deeper, it is on the part level declared. So yeah, it's not for every Tekla object, but it will be the Tekla part, or just part. Oh, sorry, some misleading. Okay, so it will be the Tekla solid. Okay, this is the first thing. And what we can do with those Tekla solids. And if we go too deeper, we can get some edge enumerator or face enumerator. And yeah, we want to construct the triangles, to get the triangles which will cover our solid. So we are at that point not very interested in the edges, but mainly on the faces. So I will get the face enumerator, and here it is. So this is the enumerator, and yeah, so we will need to go with the while approach, but I see that here is some private field which maybe we will need to get in the future via reflection. But yeah, it sounds like some optimization not done at the correct part. So let's do it like that. And here I will be able to get the face. And that face, it has the normal. Great, we have one of the properties which are needed. And also we have the loop enumerator. And it is used to get the outer, so the contour, and also the inner polygons, so holes. Yeah, and let's do it like that. I will get the loop enumerator. Yeah, loop enumerator was the previous name. So here it is, and yeah, now I don't like that. Yeah, at first let's stick with that one level of arrows less, and now maybe we will extract it just to a smaller method, which will focus only on one face. It sounds like a good idea, but at first let's try to do loop enum current. And what is the loop? So let's see what is the loop. And the loop is a list of points, but how we can get them? Yeah, we need to do it through our vertices. Not very convenient, but okay. So one more level, vertex enum, loop get vertex, yeah, and slowly we will need to do some refactoring for that because it doesn't look very stable. And yeah, here we will get the point, exactly, so it's the point, but as you can see, 3 while loops, they look awful. But that's only for one part. So yeah, for the whole scope we will need to do it once more. So okay, what we can extract? We can extract that part, because from that we want to convert the Tekla face to our face. So here I want to have some private method which will get our face, and it will accept the TSM or TSS. What is the... This is the face, it lies in the Tekla Structures solid namespace. So I will use one extra using, here it is, and here I will accept the face coming from the Tekla, and I want to transform it. So to do that, I will just grab that part, and here I want to do some magic like that. Okay, so at that point I will get the face, but of course the question is what should happen with that, and we are missing at some point the list of faces. So let's stick with the list face, and let's add it here. Here it is, and let's just fix. Okay, here it is, but white array, it doesn't, we don't need it. Okay, so the error, the compilation error from that part is solved, and now we need just to think about that part, how we can return the face. What is needed? So we need the contour, the normal, and yeah, the contour. So let's name like the contour. We don't have it, I know, but let's stick with that. Tekla face, here is the normal, and the holes. Okay, so that is how the constructor looks. And now let's think about the contour and the holes. And those are the type polygon. So the contour is coming from the first loop. So the first loop is used to get the contour. And here we are getting some points, so definitely we will need the points. And it is here, okay? So here I want to add those points in that scope. Okay, not sure that that assignment it brings any value, so we can stick like that. And yeah, we can even, okay, let's maybe not do that at that point. So here I'm getting the points, and yeah, maybe that is something what we could extract. So let's just extract, and let's name it like the transform. So we will have the transform solid, transform face, and transform loop. Okay, and what should be the result? It should be the polygon. So it will be the polygon, and here we will not return just the points, but return new polygon points. Okay, so this is solved, and here is the, how to name it, polygon. And how it can be solved? Yeah, the first idea is just to grab all of those polygons into a list and then treat that the first will be treated as a contour and the rest will be the holes. And if we will use some link you skip, then it should look quite fine. So let's create the list and let's assign it at that point. Okay. Okay, here it is, and as I said, the first polygon, it should be treated as a contour, and the rest, they are just the holes. So that it looks quite solid. Maybe not the best word, but okay. But of course, I don't know that it is working or not working. I have no possibility to check it until I will write some test. But for that, it could be nice to have something inside of our model, or just create from the scratch some model object and perform the test and then remove that object from our model. And that sounds like the best idea, but maybe not at that point. We are not solid proof development, so let's just cut some corner and create why I can do this. Okay, let's just draw something in the space. Let's expand it, and we have it. I have some wall, some very very basic wall. So I want to get the identifier of that object, and I want to check how the transformer from the Tekla to our internal solid is working, or is it not working. I just want to check the code, how it works. So yeah, I will need a new test, and it will be the Tekla to domain transformer. Okay, that will be this. It will be the test class, and then test method and identifier. Okay. As I said, this is not the best testing practice, because you need to have that kind of an object inside of your model. So it would be much better if you would have also some helper library to create the model from the scratch inside of your model, but it's definitely outside of the scope of that particular project. So now I want to test that Tekla to domain transformer. So I will create I will initialize that object and then try to transform. And of course, here we need to get the part. And for that purpose, I will write a new helper just here. And we had something which we selecting something, but yeah, we need something which will just get the object. So I want to have that part. Okay, so I will try to write a new, yeah, maybe just extract it, because it is the same logic as here. So if we will extract that method and pick it like the get model object, then after setting it as a public, yeah, just some noise, then I will use that method, that helper method, inside of my test class. So here it will be my part, and of course it's just a simplification just to make it up and running. So here it will be the identifier, and of course this is not the part, this is the model object. So I will try to use it as a part, but I don't know at the test phase that this is the part, because yeah, here we are expecting that it will be. So I need to write. Previously for the test it was the assembly, so it won't be like that. So yeah, I need to change my approach to that one. So here I will do some casting, and I hope that it will not fail. So that is quite risky, because that identifier could point to another type of an object. But yeah, I just need to get the test running. So now I'm getting the part, and here it will be my result. And of course, I don't know at that point, or maybe I know. Okay, let's assume how many faces that wall should have. This is the 3D object, just a type of stretched box. So the 6 faces. So let's try to write some assertion. The result faces should have count 6. Okay, and let's see that it will work or not. Am I wrong, or will it succeed? And yeah, it's okay. So now let's just put the breakpoint. Let's debug. So we can check that our solid, it has 6 faces, and those faces, they have some contour, which has the points, and those are related in the global coordination system. It will definitely be something which will need to be fixed later, but okay, this is what do we have. And yeah, the question at that point, should we stick with okay, maybe one more test for the points. So let's now check that the first face points contour points should have count not 1 but 4. Yeah, this is the expected result. So let's change the name, and transform returns correct geometry. Let's assume that checking just the count of faces and the count of the first points is enough at that point. We are not strictly making it as a concrete testing. So yeah, now I'm just checking that everything seems fine at that point, and I will just pass it to Git. And now what we have done, we have created some entities which will hold the geometry, and also some transformer which is able to convert the Tekla objects into our domain ones. So transformer for Tekla geometry into domain objects. Okay, something like that. And why I am now thinking that maybe it's not the best approach, because here we have the enumerable, and due to the Tekla way of getting that information, we will get those objects at once. It will be the list. It will be not deferred. No, it will be not the connection with the database when you can manipulate with the where clause. So I'm thinking, okay, I don't want to have it as a list, because it will provide some intuition for other developers that, hey, I can add some faces to the existing solid, but it's not the matter of our code. So I rather would like to use something like read-only list, because yeah, it will definitely point how many elements are there. That operation was already done. It was queried from the Tekla engine, and it will block the users from adding or removing some elements. So I will do that change. It will of course not influence on the on our test. It should not, but of course we will see. So I think that those are all of my points, but there is something wrong. Okay, here I need to change it to the array empty. And yeah, of course we have the tests. So let's check that, okay, something is wrong. So let's see what is wrong. So here I can skip. No, not really. Polygons. I have the list of the polygons. Okay, when I am using the skip method, then the return is the enumerable. So here I will just go to the array and just cast it, and let's find out that now our tests will still work. Yeah, they are working. Okay, so now we are able to transform the Tekla part into the solid. Just for one object, maybe not very spectacular, but that's, yeah, the essence how usually I am trying to tackle the problem. Because now it's very easy to just grab that method in some for each loop for all of the selected elements, but I have some tests which will at least show me that there are some compilation errors, that there is something wrong, something broken. And I think that it is quite valuable to get that feedback as fast as possible. So we have something. Maybe, yeah, I see that there is not a real strict convention. So let's just here the first change was about changing to more concrete interface. It's a strange combination that the interface should not be concrete, but okay. Here I have used that. Let's rename it, and it will be the last commit for today. Renaming test classes. Yes, I want to save them. Okay, so we have that transformer, but as we checked, it is returning the position of our elements in the global coordination system, which can be very big. And of course, it doesn't know anything about the triangulation. And for the dotbim format, we need to convert those faces, those polygons, into the triangles. But that, it will be the scope of the next material. There is one more thing which I would like to add. I think that it will be quite valuable for the later stages just to have the possibility to visualize those faces, just to draw some temporary graphics in the Tekla UI. Because based on that, we will feel that we are going to the correct direction or we had taken the bad path. So let's go back to the Visual Studio and let's think about some testing graphic drawer, something like that. So definitely it will be not the core part of the dotbim exporter from the Tekla, but it will help us in the development. And I don't want to create many projects for such a simple exporter. I want to stick with as least amount as possible. So I will just add a new class to that test helper namespace, which is quite a junky one, but you know, almost every project has something like that. And it will be the polyline drawer, just like that. Maybe not the polyline, but okay, let's stick with the polyline. The distinction between the polyline and the polygon at that point is not very big. So it will be the public class, because I will invoke method from that class from the test. So it has to be public. And what I want to do, I want to just draw. And what we will provide here, and yeah, maybe let's start with just the solid. I want to draw the solid, but our solid, our entity. So it will be this one. And the question is how it should be drawn. So in the Tekla, there is this graphics drawer. And I think that this is in the user interface namespace, but let's find out that it is truly here. So drawer, and it is truly here. Yes, here it is. Okay, but I want to stick with that naming, so like that. Oh, sorry, mistake. Okay, so the drawer class, it can draw line segments, mesh lines, mesh surfaces, but I want to draw the polylines. And for the drawing polyline, we need the object of the type graphic polyline, which resides in the same namespace. So we need some kind of a helper which will convert our not solid, not face, but our polygons into the graphic polylines. So I need some small method which will return graphics polyline transform, and it will get the polygon from our definition. So here the drawer will draw those polylines, and of course which ones. So we will be iterating through all of those faces, and here we have the face, and for those faces we will need to get what do we have here? We have the holes and we have the contours. Okay, so we want to draw two different polylines. So the first one will be for the contour. Here it is. And the second one, this is the polygon, and okay, we are missing that part. So this is our current implementation, and we want to do the same for the holes, if there are any, of course. And yeah, it would be quite strange if they will be all drawn with the same settings. So maybe some differentiation with some different colors, something like that. So let's see what is this graphic polyline, what it needs. What is the constructor of that? And where is the constructor? Here it is. But this is the default one. Okay, here we can provide the color, the width, and the line type. Probably we will not change the width and the type, but the color, why not? So those are the Tekla RGB colors from 0 to 1. So at the very beginning of that class, I will create two different colors. One, but where it is, where it was in that namespace? Yes, it was here. And it will be just the red. So for the red, it should be 1000. So it is the red, and the second one will be the green. Red, green. So it should be like that. Okay, I have two different colors. And why is that needed? Because now I will provide here needed color. So let's assume that, yeah, the contour will be the green one, more optimistic, and the hull will be the red. Here it is. Okay. And what else? Here we need to create that polyline. So definitely we will create some new object. And what is needed here? Color, width 1, and the line type solid 1. Okay, nice, but of course we are missing the polyline. So here we need to do the conversion from the polygon to the polyline. And let's do that. What is this object? From the geometry. Okay. So I will stick with that, TSG. So that is the polyline. And what is, okay, here we are accepting we need the enumerable of the points, and I think that we have it already. Here it is, but in the form of read-only list, but it will not be a problem. So it should be fine. Let's see. Okay, now I have some very basic polyline drawer, and I want to use it inside of our test. And we had the test for this one, when we are getting, not this one, Tekla domain transformer, it was here. So here we are checking just the number of faces, the number of points in the first phase, but I want now to draw. I'm doing it just for the sake of visualization purpose. It's not the part of the test, you know, it's just a helper class which will be used later when we will create some triangles, and we will want to check visually that, yeah, the code is working correctly. So here I will provide it like that. So now I'm providing the solid, and after triggering that test, it was that one. So run tests, maybe not all, but I want to run only that one. And I don't remember the shortcut, so let's find out where it is. Tekla domain transformer test y2. Okay, I have not rebuilt the solution, so let's rebuild, and then we will see that some lines will be there. So let's see that. Okay, now we have just one test, and let's invoke it. And after executing those two lines, we will have something in Tekla. And as you can see, yeah, now we are getting those green lines. Nice. But of course, we don't have the hole. So let's just check how the code will work when there will be some hole. So now I am just providing some very dummy hole. Just for the sake of this visualization, it will be the last thing which I want to do. And let's create a part cut. Is it there? Not really. I have wrongly clicked, and now it is there. So okay. Now the identifier of that wall is still the same, but yeah, my test is strict with the result. So I have, just for the sake of that, just to comment those lines, because I don't want to stop the execution at that part. And definitely we now have more faces. And what is the result? Okay, here it is. So as you can see, we are getting the red one for the holes and the green one for the faces. And yeah, we are missing one line of that hole, so probably our polygon is not close one. So when we are converting it to the polyline here, we are missing the last, yeah, the first point. So is this read-only collection? No, this is the array, so we can definitely add just for the sake of visualization that part. And now after retriggering, Of course, the question is if the green will be on top or the red one, because yeah, what is the hole for one face is the edge, normal edge, the contour edge for the second one, but now we see that all of those are red ones. So, okay, we have it. And just to not spoil our test, I will now, oh, it looks very nice if you just remove or yeah, change the representation. Okay, so I am removing that hole just to preserve the previous shape of our wall. I am not spoiling with the test, so that is not needed. Here it was just for the sake of visualization, and for now I am just now triggering only all of those tests, and when I will see that everything is green, then okay, the job is done for the part, the pure Tekla part. And yeah, here it is. So we are able to get the geometry from the model. And yeah, the next question is that we need to tessellate it. We need to cover that polygon with some triangles. And that will be the part of the next video. So thanks for today, and we will see later.